Hello everyone, I'm Orestes, and in today's tutorial we're going to have a first look at the Formula Effector. You can find formulas like this in many tools inside Cinema 4D, such as the fields or Expresso or even shaders. And it's a great helper to make parametric animations. So let's take a look how it works. I'm going to make a new scene and make just a few clones to see how the formula is working on them. Let's start by making a plane effector. So the plane effector, by default, it's just rising the clones up and it's giving the same value to every clone. So let's compare this to the formula effector. So I'm going to make a formula effector and I'm going to use the same values over here. So just rise them up like this. Alright, so we have the same parameters, but it looks totally different. And if I hit play, they are moving up like this, which is interesting, but the formula might look a little bit intimidating. So basically, the formula, it has a function in here, and this function gives a value. And it gives a value for each one of these clones, and it's a different value, basically. So let's simplify this and put a constant value. So let's start by using a value of 0. So this gives a strength of 0, basically. If I give it a value of 1, this will give them a strength of 100%. So basically now it is identical to the plane effector. We recreated one effector just with one single digit on the formula. And then we can use like 0.5, it's going to give half the strength. We can use minus 0.5, so we can use a value of 2 to get 200% strength. So this is like a factor. It's multiplying this to the strength of the effector, and it's going to give you the corresponding result. We can also do things like additions. So I can say 2 minus 0.5, and now I'm getting 1.5 basically, but it stays here on this form. You know, it's calculating what's the result, is giving it. But this is not very interesting because all of the clones have the same value. If we want to vary the value for each one of these clones, we're going to use variables. As the name suggests, it means the values will vary. So if we say, for example, the index, if I use the index here, then everything has the different value. So what values are these? Let's select our matrix object, go to the transform tab, and display the indices of the elements. You cannot see it because they're white. So let's use a color here. So now you should be able to see the index number. Each one of these clones have a different index, and this index is being applied to the formula. So I'm using this placeholder variable, and then it says, okay, this clone will have a value of 0. This clone will have a value of 1. So it has 100% strength. This clone will have a value of 2. And then you can do functions on this. So we can say minus 2, and then it drops everything down. So this clone has a value of minus 2, this has a minus 1, this has 0, because 2 minus 2 is 0. How can we constrain this to be between 0 and 1? Because this is like 0 and 100%. Well, it starts from 0 and then it goes all the way up here, which is like 400%. What do we have to do to drop this to 1? Well, we can divide it. If we divide 4 by itself, it gives us a value of 1, right? So if we divide this by 4, everything by 4, then we squeeze everything to values between 0 and 1. Okay, that's cool, but if we increase the count now, you see it's going higher, because now I have to divide it by 8. So I have to divide this by 8. It would be cool if we could, you know, automate this, and we can with another variable. There is a variable here for the object count. So instead of typing the number, we can say count, and then it will say how many elements do you have here. There are 9 elements basically. So it's always going to divide it by the total number of elements. Now, if we increase this or decrease this, you see it will never surpass the value of 100%. It will always be a little less than 100%. If we want it to go to exactly 100%, well, we want to divide by the highest index. So this will be, because it starts from 0, we have to subtract -1 from the count, but this is not going to work because the divisions have priority. So we need to use a parenthesis on the count. So we say ID divided by 1 less than the count. So now it's exactly 100%. And what we have created is the step effector. So we already created two effectors, the plane effector and the step effector, and that was pretty easy. But not only we can vary values between the clones, we can also vary values between the frames, for example. Now it's not changing. It has the same value on every frame, right? There is another variable, this one, which is for the time. So if we use this, t, then you see it has different values for different frames. And basically this is the time in seconds, not in frames. So at frame 30, it's going to be a value of 1. If I type 1 here, you see it doesn't change because it's the same. If I go to frame 60 and I say t here, this will be the same as a value of 2 because it's 2 seconds, because I'm at 30 frames per second. It's the same as saying 2 here, it doesn't change. And this is a good thing because the animation will stay stable even if you change the frames per second on your document. What we have created here, if we let it play, you see it's just rising up because t is rising, basically it's increasing. And we have created the time effector. Already we created 3 effectors with very simple formulas over here. But additions and multiplications are not the only thing we can do. So if we right click and we show the help, every formula object will have a link to take you to the list of possible formulas. So if you click it, you can see all kinds of functions that you can use inside your formula to spice it up. So one of the most useful ones is the sine wave. So sine wave is like working on a circle. So you have a circle and it has degrees, right? So a circle is 360 degrees total, 360 degrees. It starts from, let's say here. So this is 0 degrees, then this is 90 degrees, this is 180, and this is 270. And then it goes back to 360 over here, right? It's the same. And the sine wave is like you have like a line on the bottom, and here is 0, right in the middle of the circle is 0, and over here is 1, and over here is -1. Okay, so basically a sine of 0 is going to give you 0. Let's use some color here. A sine of 90 is going to give you 1. A sine of 180 is going to give you 0 again, the same as this one. And then a sine of 270 is going to give you -1. So as it goes around, it's going to make this loop, and it will never exceed the range of -1 and 1. That is why it's so useful for us. So why don't we try it? Let's say sine wave of 0, okay? And you see it drops at 0. Sine wave of 90, it goes to 1 because 90 goes to 1. Sine wave of 180, it goes back to 0. Sine wave of 270, it goes to -1. And then 360, it goes back to 0, okay? So let's try to use a variable here. Let's use the time variable. So if I hit play, it starts rising up, but it's going very slowly. So let's think about what is the value at frame 90. So at frame 90, the value of t is 3, right? Because it's 3 seconds. So it's very, very small. It's like over here. The value hardly changed, right? So we need to multiply this. How's about we multiply this with 360? So if we go to frame 30, t will be 1. And if we multiply it by 360, it will be 360. 1 times 360, it will be 360. So between 0 and 30, it makes a full circle now. So we made a full loop, a perfect loop that lasts 1 second. Okay, and then it repeats. So let's hit play, and we see it's just oscillating up and down. And so this goes a bit fast. If we want to slow this down, then we have to reduce our multiplication, right? So how's about if we want to make it 2 times slower, we divide it by 2, right? So now you see it's 2 times slower. It takes 2 seconds to make a loop. If we wanted to make 3 times slower, we divide it by 3. Now it's a 3-second loop. It's a perfect 3-second loop. And we can use a variable for our division to control it easier. We have an extra value over here that we can drop inside our formula. So this is called f, right? It's called f for frequency. And its value is defined by this slider. So we can use this slider to animate it instead of typing it, basically. And it has a keyframe dot and everything. So if we set this to 3, it's like dividing this by 3. So now it's a 3-second loop again. Okay, so this is a sine wave animation, and it's using the time as a variable. So what if we want to offset this? So let's say we are at frame 0. Okay, we're at frame 0, t is 0. This is sine wave of 0. It's the same thing as saying sine of 0. What if we want each one of these clones to have a different position on the circle? Well, we just have to add a different number. So let's say we want this clone to be sine 0, but the next clone we want it to be sine, let's say 20 or 30, sine 30. And then the third clone we want it to be sine 60, right? So we can create an offset of degrees inside the sine wave. How do we do that? Well, we just add to this number, right? Here we need to add 30 to make it sine wave of 30, right? But we want it to be per clone, so we add the ID number. But the ID is not 30, it's just 1, right? It's just going on increments of 1. If we want to make it on increments of 30, then we say ID times 30, right? So we just added increments of 30 degrees inside the sine wave. Let's remove the annotations there. So now each one of these clones have an offset of 30 degrees within our sine wave. Okay, so with everything we have learned so far, let's go to our previous scene and try to do this animation. So let's use a value of 1 here. It doesn't do anything, it's just moving the clones up. From 0, it takes them up 50 centimeters. Okay, we know we're going to use a sine wave with time. So we use a sine wave t times 360 to make a 1-second loop. And then it makes 1-second loop. It goes too fast. So we divide the 360 with f, so we can control it from here. And then whatever number we put here, it will be the number of seconds this loop will last. So now it's a 3-second loop. It's just moving up and down. Here's a hint. The default time from 0 to 90 degrees is not 3 seconds. It's 3 seconds and 1 frame. So it's not the perfect 3 seconds. If you want to make your project range 3 seconds, you need to decrease it by 1 frame. So here I start from frame 1 instead of frame 0. And it's a perfect loop. All right, and then to offset these guys, we can offset them by 30 degrees by adding inside the sine wave ID times 30. And then we have an offset like this. Okay, so we created our first part of the animation. So when you're using additions and actions, basically some functions have priority. So if you use, for example, 2 times 2 plus 3, right? So what is the result of this? Well, the multiplication will happen first. It has priority. So it's going to be 2 times 2, it's going to be 4 plus 3. So this is going to be 7. If you want to say that this will have priority, you need to put it in a parenthesis. So if you put it in parenthesis and you say 2 times 2 plus 3, this will be the same as saying 2 times 5. 2 plus 3 is 5, so this will be 10, right? So that's the difference if you want to control the priority of actions. This is not something we need right here, it's just something important you need to know with the formula. So multiplying a number by itself, what will happen if I multiply this by itself? We can do this by copying and pasting the formula and putting a multiplier in between. Let's multiply it another time. You see, I multiplied it 3 times. And now we're getting a very different animation. So if we think how this works, so the sine wave goes from -1 to 1, right? To +1. This is the range of the sine wave. What happens if you multiply this by itself? If you multiply -1 by itself, well, the negative things are gonna cancel each other out and it's gonna become positive. 1 by itself is gonna be the same thing, 1. So this will become a range from 0 to 1. Well, if you multiply 0 by itself, obviously it's gonna stay at 0. All right, but what happens if you multiply something by itself 3 times? Well, that's actually interesting, because if you multiply -1 times -1 times -1, then 2 of them are going to cancel each other out, but the third one is going to survive the massacre and it's going to give you -1. And if it's +1, then it's just going to be +1. So if you multiply 3 times something by itself, it's still going to be a range from -1 to 1. But actually the in-between values are going to change, because 0.5 times 0.5 is not going to be 0.5, it's going to be 0.25, right? So the in-between values are changing. But our formula became super messy, right? So instead of copying and pasting it 3 times, we can use one of these functions. We can use the power function. So it says power, and then you put A is the value and B is the exponent. So we can say power, pow, open a parenthesis, then we put the value we want to multiply, and then we say how many times we want to multiply it with itself. So in this case it's 3 times, right? And then we're getting the same result. So I use this for the rotation, basically. So we make a copy of this and we say this is the rotation. We change the parameters from position to rotation. We drop it into the letters here. Okay, and then, so right now it's completely the same formula, and we see it doesn't look so interesting because it doesn't have any offset at all. So let's try to use our pow on the rotation with an exponent of 3. And now we get something a little bit more interesting. So this is the introduction to the Formula Effector. I hope you found it useful, because the same logic is going to help you with nodes and with Python programming. It's really a very useful stepping stone to these tools. but it's a useful tool in itself as well. I hope you enjoyed the tutorial and see you next time.